All right, I hope your day is going well and that you're excited to learn some math. Today, our goal is to understand and be able to write domain and range in multiple ways. Now, you should have done this a little bit in Algebra 1. We're going to go a little bit further today, I hope. The key language we want to know here is what a domain is, what a range is. We're going to need to understand the words continuous and discrete. And a new thing some of you may have seen, but most of you may not have, is interval notation. So let's get right into it. The domain is the set of all input values, x values, that produce an output. Now, sometimes I see kids say domain is x, and that's not true. Domain and x are not the same. Domain is all the things we can put in for x. What are all the things we're allowed to put into a function? The range is likewise the set of all output values, or y values a function can have. So we take a function y equals f of x. The range is what we're allowed to put in. What are all the different things we can put in for x? And I hope I said the domain there. The domain is all the things we can put in for x. And the range is what are all the different answers we can get out for y? What are all the different possible outputs we can have? So before we get more deeply into it, let's talk about what the word continuous means. A function is continuous on, and this might not be something you're familiar with. This is called interval notation. It looks a lot like a point, but if you see parentheses or brackets or a mix of parentheses and brackets, we're describing all of the values between a and b. So the way we read this is continuous on the interval from a to b. That's how we read this. This is the interval from a to b. And a function is continuous on the interval from a to b if it has no breaks. In other words, if you can make it without picking up your pencil. So a graph that looks like this is continuous. It could have arrows on the end or not. It doesn't really matter. The question is, could you make it without picking it up? It doesn't even have to be a function. This is continuous because I made it without picking up my circle. Some things that are not continuous, would be something like this. I had to lift up my pencil and there is a break here. Something that is not continuous is this, because again, I had to lift up my pencil to make it. I couldn't make it without lifting it. You know, there are all sorts of things that are not continuous. All of these things, they have breaks in them. I had to lift up my pencil to make them. All of these are continuous. I was able to draw them without picking up my pencil. Okay, so these are continuous. And again, it doesn't matter if there are arrows at the end. If I put an arrow on this ... thing, it's still not continuous because I had to pick up my pencil along the way to make it. So, a function is, on the other hand, discrete on, how do you read this out loud? Discrete on the interval from a to b if there are a countable number of x values for which the function is defined. And countable means that I could count them. There's 1, 2, 3, 4, 5, but eventually I could count all of them and feel comfortable that I will get to them all. You'll notice that on a function that is continuous, I can't just count the x values because all of the in-between x values happen. So maybe there's an x value at 1 and at 2, but also at 1.1 and 1.037. And all of these in-between x values, I couldn't just list them out. And if you can't just list out the x values, the function, if you can list out the x values, the function is discrete. This was the only example of these 6. This is the only one that was discrete because it has individual x values. There's an x value at -2, -1, 1, 2. And in fact, even though there's arrows at the end, I can just keep counting them. 1, 2, 3, and listing them out, and that's okay. Okay. So a function is continuous if it has no breaks. A function is discrete if there are countable number of points. Let's look at some examples of discrete functions first, because they're a little bit easier to do with domain and range. This table, and in fact, all tables, unless additional information is given, all tables are discrete. Now, if they give us more information, like that the function is continuous and that this is only some of the values, or if there's an equation that goes with it that produces more values, we could have a table that's continuous. But if they just give us a table, we have only a set of countable x values. So the domain is what are all the possible input values that have an output. And we can see them right here. The domain, and we're going to write this as a set. We use curly braces. This is called set notation. When we make a set, and we can just list them out. And we always go from lowest to highest. So we start with 1, and then the next number 2, 3, and 4. These are all of the inputs that have an output. That's it. And we close it with braces at the end. We go from lowest to highest, and we never repeat any values. So even if 4 happened 3 times, we would only write 4 once. These are the values that produce an output. The range is all of the output values. And the same thing holds true where we go from lowest to highest and we don't repeat. So let's look. The range is all of the output values. Here are all of the possible y values. The lowest y value is -1, and it happens twice, but I only write it once. -1, 3, 5. This is the set of all possible output values for this function. These are all the inputs. These are all the outputs. All right, try it on your own in g of x. The domain is all the input values. And hopefully you got that the input values in order are 1, 2, and 3. And go ahead and try to put the range. What is the range of g of x? Those output values were in order. Be careful you put them in order. 2, 5, 7. Even though 5 came first, 2 is lower, and so it goes first. You'll notice I put D and R here. There will be some times in this where I just put D and R instead of writing out domain and range, and hopefully you feel very clear about what those are. I'm sorry my voice is a little scratchy today. All right, h of x is a different type of function. Here we have a list of points. Each point has an x value and a y value. The domain is still all the possible x values for which there's an output, and I see 3 different x values. I need to go in order from lowest to highest. -8, then 2, and then 3. Those are all of the possible inputs. The range is all the possible outputs, and go ahead and write that on your own. And hopefully you got them in the right order and wrote that the outputs are 1 and 7. Notice that even though 1 happened twice, we only write it once. And we write it before we write the 7. So these are all the possible inputs for the function. These are all the possible outputs. Graphs can be discrete as well. Notice that we have only individual points. They are not connected. And we can count how many there are. 1, 2, 3, 4, 5, 6. That's it. The domain is all of the possible input values. And we find the input values on the x-axis. So what are all the possible input values? Well, there's an input value here, and here, and here, and here, and here, and here. Those values are, again, in order from lowest to highest. And when you're on a graph, it's really easy because the lowest to highest goes from left to right for domain. And the lowest x value is at -1. The next lowest x value is at 0. There's an x value at 1, 2, 3, and 4. And each of those x values has an output. And so that's the domain. The range is all of the y values. And y values will go from bottom, because that's where the lowest y values are, to top. So we'll start by writing what's the lowest y value. And the lowest y value out of any of these points happens here, because this y value is at 0. This point has a y value of 0, and so that's what I'm going to write first. 0. The next lowest y value is right here at 1, and it happens 2 times, but I'm only going to write it once. The next lowest y value is right here, and the highest y value is right here. Notice we went from bottom to top. There's a y value at 0, 1, 2, and 3. And so we write that out. 0, 1, 2, and 3. And notice they didn't correspond to the point. So even though we wrote -1 first, that y value was the second y value that got written. They don't have to come in the same order. We just need to go from lowest to highest. All right, let's look at this next graph. This is g of x, and I want you to try this on your own. What is the domain? What are all the possible x values that happen here? And hopefully you got it right, that you looked at the x values, and the x values for these 3 points are 0, 1, and 2. And so we write it out in order, 0, 1, and 2. Notice that those values went from left to right. Go ahead and write what you think the range is. What are all the possible output values for g of x? And hopefully you got it right, and that the only possible output value is 2. That's the only output value for this function, and so the range is just the number 2. And we write it in a set like this because we're saying that's the set of numbers that could come out. This one's a little bit different because it has an arrow on the end. And so I'm going to show you an example here. The domain is all the possible x values. And again, we start on the left. The lowest x value is -1. So I'm going to start listing it out. -1. The next x value is at 0. The next x value is at 1, and then at 2. And then there's an arrow on the end. And that means it will keep going in the same pattern. And so even though there are individual values that keep going, we can write a ... at the end. It's still discrete. We can write it like this because this pattern will keep going. There'll be an x value at 3 and at 4 and at 5. The range, we have to be a little bit careful. Remember, we start from the bottom. So what is the lowest y value? Well, there's an arrow here. It keeps going down forever. And so we can start with a ... saying, look, that they'll keep being lower and lower negative numbers if we go to the left. But the lowest y value we see here is at -2. And then at -1. And then at 0, there's a y value. And then at 1, there is a y value. So for the y values, we always start at the bottom and then go up until the highest y value. So notice these ... mean the pattern keeps going. Here, the x values will keep going to the right. Here, the y values will keep going down. But since we're going from lowest to highest, we have to start with the ... there. Okay, let's look at some continuous functions. Here we have f of x, and we're going to write this in a couple of ways. Let's start with the domain. What are all the possible x values? And let's start with why we can't write it like we did before. Why can we not just say -2, -1, 0, and 1? Well, this time it's a connected function. Remember, that's what makes it continuous, is that there's no breaks here. It doesn't matter if there are arrows on the end, it's just that there aren't any breaks. And because there aren't any breaks, all of the x values in between -2 and 1 happen. There's an x value at 0.375, right? Like 0.375. We can't write that. We can't write out all the different decimals that might occur. We would be here forever. And so instead, we have two main ways of writing it. One is with inequalities, and we just pick the domain. We go left to right, because that's smallest to biggest. The smallest x value is on the left, and it's -2 is less than x is less than the biggest x value is 1. And I want to point out a couple of things. You might notice that we will always, when we're doing this in-between thing, it'll be the lowest value, and then less than the variable, less than the biggest value. So you'll always use two less than signs, low, less than, variable, less than, big. And this will be the same for both domain and range. The other thing you may have noticed is that I used a less than sign here and a less than or equal sign here. That's because there is an x value at x equals 1. But there's a blank circle here, which means there is no defined value at -2. There's no output at -2. In other words, f of -2 is undefined. And since -2 does not have an output, we don't want to include it in our domain. So if there is a point at the end, we would put or equals to, and if there's not, we don't. The same thing will happen with the range. The lowest y value, just like before, goes from bottom to top. So the lowest y value here is 0. So we write 0, that's the smallest one, less than y, less than, the biggest y value is 3. And again, you may have noticed that I put a less than or equals to at the bottom because there is a y value at 0. But there is no y value at 3. There's no output there because of that blank circle. And so it's 0 less than or equal to y less than 3. Again, notice that it always goes less than, less than. So lowest, less than the variable, less than the biggest. Okay, now we have what might be new for you, a way to write this using interval notation. Earlier, we talked about how sometimes we use parentheses and brackets to write an interval, and let's see how that works here. The domain is all the possible x values, and we said the x values were all the numbers in between -2 and 1. And so we can write that in interval notation like this, -2, 1, bracket. We use a parentheses when it is not equal. So I'm going to write this right here, parentheses, not equal. A bracket is when there is that value. It includes that value. So there is the value of 1, but there wasn't the value of -2, so we don't include -2. It does not equal -2, and it does include 1. Similarly, the range, we know it's going to go from 0 to 3. It includes it, so it needs a bracket. So it includes the value 0, and 3 needs a parentheses because it does not include it. So if it, I guess instead of saying not equal, I should say not included. So the endpoint is either included or not included, and it matches up exactly with whether we used an or equals to sign. So 0 less than or equal to, bracket. 1 was, x was less than or equal to 1, we needed a bracket. But when it doesn't have the or equals to sign, we use a parentheses. Okay, let's look at, you guys are going to try one on your own real quick, and then we're going to look at g of x. So g of x is this function. It has arrows on the end this time. That will change things slightly. The domain is the x values. And we always start on the left because that's where the smallest x is. And I see that there's an arrow pointing to the left. That means that the smallest x value, there will not be a smallest x value. We will keep going left and left and left towards -infinity. And so we write that. -infinity is less than x, which is less than, so value less than, variable less than. What's the biggest one? Well, the biggest value, there's an arrow on the right as well. And so the x values will keep going left and keep going right. We say that the domain is all the numbers between -infinity and infinity. And another, if we get a situation like this where it's all the numbers, we can write all real numbers, or we can write this R with a double line at the beginning, okay? So all real numbers, or this is the set of all real numbers. And the range is not all real numbers. Not all the outputs happen. We always start from bottom to top. And so what is the bottom of this? Well, the lowest y value is right here. What is that lowest y value? It is 0. So 0 less than or equal to y, which is less than, what is the biggest y value? Well, it keeps going up and up and up, and so it goes to infinity. So the y's are between 0 and infinity. If you have an infinity on one end, another way to write this is just say y is greater than or equal to 0. All the y's are above 0 or equal to 0. Let's see how to write this. With domain, we put parentheses, -infinity, comma infinity. This is an interval notation. And we used a parentheses because it did not include infinity. We will never use or equals to on infinity, and we will never use brackets on infinity because it never includes the x value of infinity. X never actually gets to infinity. That's not a number. The range, there is a y value at 0, so that needs to be included. So what symbol should we use to include that? We use the bracket. Bracket 0, comma, infinity. And what symbol should we use for the infinity? Should we use a parentheses or a bracket? We always use a bracket because the y values go between 0 and they keep going up and up and up, but they never actually get to infinity, and so we don't include that value in our range. All right, Let's see how you do. I'm going to let you guys try h of x here. I'll go over it in a second. What is the domain in using inequalities? So the domain, we should go from left to right. The leftmost x value is -1, which is less than or equal to x, which is less than infinity. X goes between -1 and infinity, and it could equal -1, and we never use or equals to for infinity. Go ahead and try the range. The lowest y value it keeps going down and down and down. So it goes from -infinity, which is less than y, which is less than or equal to the highest y value of 2. Because there's only infinity on one side, another way we could write this is just y is less than or equal to 2. This is also fine. In fact, this is the way we will usually do it if it's one-sided. Let's see how it goes in interval notation. Try this on your own. Try converting this to interval notation. You should have gotten bracket -1, comma, infinity. The x's go between -1 and infinity, but it includes the -1. That's what the bracket means. We always use parentheses for infinity. The range goes from -infinity to what is the highest y value? Well, it's 2, and that needs a bracket. So this is interval notation. Practice it a little bit. All right, one thing to note is that if we have an equation, unless there is something specified, it will usually have a domain of all real numbers. We will learn later in the year that there's certain things we're not allowed to do, like divide by 0 or take the square root of a negative. But most functions, when we have an equation, will have a domain of all real numbers. And that means that the x's go from -infinity to infinity. Notice smallest, less than x, less than infinity. What are two other ways to write this? There are three other ways to write this. Let's see. -infinity, comma, infinity. This is an interval notation. Notice we did not use brackets because we never equal infinity. We could also write all real numbers. We could also write all real numbers. My phone is telling me it's low on batteries. And the symbol for this is this double R, this double line R, all real numbers. X could be anything. This means the possible inputs are anything. Why wouldn't we be able to put in anything for X? Now, to find the range, you actually need to know a little bit. You need to know that linear functions make a straight line. And so the y values we can see from it here are also all real numbers, and we can write it in exactly the same way. The only thing that would change is in the inequalities, we would put a y instead of an x. But the interval notation is the same, and the all real numbers is the same. Okay, so for the domain here, what are the numbers we're allowed to put in? We're allowed to put in all real numbers. Go ahead and write this 3 different ways. How else can we write all real numbers? And hopefully you got that we could write the interval from -infinity to infinity. You can also write -infinity is less than x is less than infinity. And you can write all real numbers out in words. So all real numbers. The range. What is the range? Well, again, you have to understand what are the possible outputs. When you square a number, we only get positive numbers or 0 out. 0 squared is 0. A negative times a negative is a positive, and a positive times a positive is a positive. And so the y values are all the numbers that are greater than or equal to 0. Try to write this 3 in a couple of different ways. Hopefully you got 0 to infinity, because it's all the numbers between 0 and infinity, including 0, but not infinity. And you should have also gotten 0 less than or equal to y less than infinity. We never equal infinity, so that's what's going on there. Hopefully you feel pretty good about domain and range. You'll get to practice some more later this lesson. Have a good rest of your day, and I'll give you some chances to practice this in just a second.